In the night sky, there is one object that feels more familiar than almost anything else beyond Earth. It rises without effort. It drifts without sound. It changes its shape from night to night, yet somehow never seems to turn. No matter the season, the location, or the century, the same face quietly looks back. For as long as humans have watched the sky, the moon has appeared steady and dependable. It marks time, guides calendars, and lights the dark when the sun has gone. It feels constant in a universe that otherwise refuses to sit still. Welcome to the Sleepy Scientist. If drifting through calm questions like this feels comforting, you're very welcome to subscribe and join these quiet explorations. And if you feel like it, sharing where in the world you're listening from tonight is always appreciated. It is gently reassuring to imagine how far these thoughts travel. Hidden within the moon's familiarity is a subtle oddity. The moon moves, it travels through space, it orbits the Earth continuously, and yet from the ground it never appears to rotate. The same pattern of shadows repeats. The same craters return. The same bright plains reappear, night after night, year after year. Half of a world remains unseen, not because it is concealed in darkness, but because something deeper is at work. At first glance, this feels almost impossible. In a universe where everything spins, drifts, and changes, how can a celestial body remain so visually constant? How can motion exist without obvious turning? The answer is not hidden in trickery or coincidence, but in gravity acting patiently over immense stretches of time. This quiet relationship between Earth and Moon was not always so calm. Long ago, both bodies moved very differently. Their motions were faster, closer, and far less settled. Over billions of years, invisible forces exchanged energy, slowed rotation, and shaped a rhythm so precise that it now feels natural, even inevitable. Understanding why only one side of the moon is ever visible is not just about the moon itself. It is about how gravity behaves when given enough time. It is about how motion can soften into balance, and it is about how the universe often prefers slow solutions over sudden ones. Tonight's journey follows that gentle process, not with sharp equations or hurried explanations, but by moving patiently alongside the moon itself. From its restless beginnings, through the quiet influence of tides, and into the stable arrangements seen today. Settle in, let the moon rise slowly, and let its stillness begin to make sense. The moon has a way of slipping into the background of everyday life. It rises while attention is elsewhere. It hangs above rooftops, trees, and quiet streets, asking very little in return for its steady presence. Night after night it appears, dependable and familiar, like a fixture rather than a destination. Most evenings it barely earns a second glance. There it is again, pale and calm, following a path that feels predictable. Sometimes it is full and bright, sometimes thin and delicate, sometimes missing entirely. Yet even as its shape changes, something about it remains strangely constant. The patterns on its surface do not wander. The dark patches do not trade places. The bright scars do not drift from one edge to another. The moon seems to change, but it never turns. This constancy is so complete that it often goes unnoticed. Human perception is very good at ignoring what does not demand attention. When something behaves the same way again and again, it becomes part of the scenery. The moon becomes background light, a gentle companion rather than an object of curiosity. And yet, if one were to pause and truly look, the oddness becomes clear. Over weeks, months, and years, the same arrangement of marks always returns. The same large dark plains, shaped like splashes of ink. The same lighter highlands, densely pitted with craters. the same familiar contrast that artists, poets, and storytellers have described for thousands of years. It does not matter where one stands on Earth. From the northern hemisphere or the southern, from deserts or coastlines, from cities glowing with artificial light or fields untouched by it. The moon may appear tilted or flipped depending on location, but its face is always the same. A single hemisphere has been quietly presented to Earth for as long as humans have been around to notice. This repetition is precisely what makes it easy to miss. The mind is drawn to novelty. It notices sudden motion, unexpected change, or rare events. A shooting star demands attention. An eclipse stops people in their tracks. But a steady presence, repeating itself night after night, becomes invisible through familiarity. There is a gentle irony here. The moon is moving constantly. It is never still. It travels through space at great speed, tracing a smooth path around Earth. And yet, to the casual observer, it appears almost fixed. Its motion is subtle. Its changes are slow. Its rotation, if noticed at all, is hidden behind the illusion of sameness. Even the changing phases can distract from the deeper pattern. The moon grows and shrinks in apparent shape, waxing and waning in a steady rhythm. These changes feel dynamic enough to satisfy curiosity. They give the impression of movement and variation. But beneath that shifting light and shadow, the orientation of the moon's surface remains locked in place. The same features disappear into darkness and re-emerge into light. They do not travel across the face, they simply take turns being illuminated. It is like watching a familiar room at different times of day. Morning light enters from one angle, evening light from another, but the furniture never moves. This familiarity has shaped human culture in subtle ways. Ancient calendars were built around the moon's phases. Stories were told about shapes seen on its surface. Faces, animals, symbols, and landscapes were imagined in the same patterns generation after generation. The moon became a shared reference point, a cosmic constant linking people across time. And yet, despite all this attention, one fundamental detail often escaped notice. The moon never shows its other side, not sometimes, not briefly, not by accident. Always the same half, presented with quiet consistency. It is tempting to assume this must be coincidence, or perhaps the result of clever perspective. After all, many things appear fixed when viewed from a single angle. But the longer one thinks about it, the stranger it becomes. A spinning object should eventually reveal all sides. A rotating sphere should not hide half of itself indefinitely. This is where familiarity becomes deceptive. The moon has always been there, doing the same thing, so it feels natural. But natural does not always mean simple. Often it means that the process responsible has been unfolding for so long that it no longer feels like a process at all. There is also comfort in this repetition. The moon's constancy provides reassurance. In a world filled with rapid change, the steady return of the same lunar face can feel grounding. It is a reminder that not everything is in a hurry. Some patterns move slowly enough to feel eternal. This emotional connection matters. Understanding often begins not with facts, but with noticing. Before equations or explanations enter the picture, curiosity has to be gently awakened. And the moon offers a perfect opportunity for that awakening precisely because it feels so ordinary. The question is not why the moon looks this way tonight, but why it has always looked this way. Why the same arrangement has followed humanity through history. Why explorers, astronomers, farmers, and night walkers all saw the same familiar face looking back at them. There is a soft humour hidden in this realization. The moon, often associated with mystery and change, is actually one of the most predictable objects in the sky. It is dramatic in poetry, yet conservative in motion. It is restless in myth, yet disciplined in physics. Recognizing this contrast is the first step toward understanding what is really happening. The goal is not to rush toward an answer, but to sit with the question long enough for it to feel meaningful. Why does something so clearly in motion appear so visually fixed? Why does repetition disguise complexity so effectively? Tonight, the moon will rise again. It will do so quietly without announcement. Most people will glance at it briefly, if at all, and continue with their evening. And once again, the same familiar face will be there, unchanged, waiting patiently. That patience is not accidental. It is the result of deep time, subtle forces, and a relationship shaped slowly by gravity. But before any of that is explored, it helps to simply notice what has always been there. A world that moves without turning, a companion that changes shape but not orientation, a face that never truly changes, no matter how many nights pass beneath it. When people hear the phrase "one side of the moon," it often brings a very specific picture to mind, a bright, familiar half facing Earth, and somewhere beyond it, a hidden region locked in endless night. A dark twin that never sees sunlight, never changes, and never reveals itself. It is an understandable image. It feels intuitive. After all, if one side always faces Earth, then surely the other must always face away, wrapped in permanent darkness. But this idea, while poetic, is quietly misleading. To understand what one side actually means, it helps to slow the thought down and separate a few ideas that often get bundled together. Facing Earth is not the same as being dark, and being unseen from one place does not mean being unlit everywhere. The moon does not have a light side and a dark side in the way that phrase suggests. Instead, it has a near side and a far side. One side happens to face Earth consistently, the other simply does not. Both sides experience day and night. Both sides receive sunlight. Both sides spend long stretches illuminated and long stretches in shadow. The difference is not about light, it is about perspective. From Earth, the same half of the moon is always oriented toward the ground beneath. That is what is meant by one side. It is a statement about what is visible from a particular vantage point, not about what exists in darkness. This distinction matters, because much of the confusion comes from mixing up visibility with illumination. Light behaves independently of observation. The sun shines on half of the moon at any given moment, just as it does on Earth. The dividing line between lunar day and lunar night slowly moves across the surface as the moon travels through space. Sometimes the side facing Earth is brightly lit. Sometimes it is partially lit. Sometimes it is barely lit at all. During a new moon, the side facing Earth is mostly dark, while the far side is bathed in sunlight. At other times, the near side glows fully, and the far side lies in shadow. So the idea of a permanently dark half dissolves once light is separated from location. Darkness on the moon is temporary, just like darkness on Earth. It comes and goes, following a steady rhythm. This rhythm is what gives rise to the moon's phases. The phases are not caused by Earth's shadow except during rare eclipses. Instead, they are the result of how much of the sunlit portion of the moon happens to be facing Earth at a given time. As the moon moves along its path, the angle between the sun, the moon, and Earth changes. Sometimes most of the illuminated surface is visible. Sometimes only a thin sliver is. Sometimes almost none of it is pointed in Earth's direction. The moon itself does not change shape. The light simply falls differently. This can be surprisingly difficult to picture at first, because everyday experience offers few perfect analogies. But it helps to imagine a sphere held at arm's length, lit from one side by a lamp. As the sphere is moved around the lamp, the bright portion remains fixed relative to the light source, while the visible portion changes relative to the observer. The sphere is always half lit and half dark. What changes is which part of that lit half is facing the observer. The moon behaves in much the same way, except on a vastly larger scale and with a much slower pace. What makes the moon special is that throughout this entire cycle, the same surface features remain oriented toward Earth. The lighting slides across them, shadows lengthen and retreat, craters appear sharper or softer depending on the angle of sunlight, but the landmarks themselves do not wander. This is why the phases can be misleading. They create the impression of rotation. A crescent seems to grow into a half moon, which becomes full, then shrinks back again. It feels dynamic, almost like the moon is turning to show more of itself. In reality, the moon is simply being lit from different angles. It is not revealing new territory. It is repainting the same familiar landscape with changing light. There is a quiet elegance to this arrangement. The moon offers variation without reorientation. It changes its appearance while holding its posture steady. For the human mind, which often equates change with motion, this can feel counterintuitive. Language has not always helped. The phrase dark side of the moon has a strong hold on imagination. It sounds mysterious. It suggests secrecy and hidden worlds, but scientifically, it is a poor description. The far side is not darker on average. In fact, it receives just as much sunlight over time as the near side. If anything, the far side is more familiar with sunlight during the new moon, when the near side faces Earth in darkness. During those nights, the side hidden from view is glowing brightly, unseen but not unlit. This realization gently resets intuition. It encourages a shift away from thinking in terms of fixed light and shadow, and toward thinking in terms of angles, perspective, and motion. The moon is not divided into moral halves of light and dark. It is simply participating in a geometric dance. Understanding this also softens the mystery without removing it. The question is no longer why half the moon is dark, but why the same half is always facing Earth. The puzzle moves from illumination to orientation. That shift is important because it clears away unnecessary complications. Once light is no longer the focus, the explanation becomes calmer and more precise. The moon is not hiding. It is not withholding. It is not behaving strangely for dramatic effect. It is simply maintaining a consistent orientation while travelling through space. This consistency is the real phenomenon worth noticing. Not darkness, but alignment. Not secrecy, but steadiness. A world that keeps its face turned toward its companion, regardless of where the light happens to fall. There is something quietly reassuring about this. Even when the moon appears thin or absent, even when clouds pass in front of it or city lights drown it out, its orientation remains unchanged. The same face is there, whether it is visible or not. By clarifying what one side actually means, the moon becomes less mysterious in one sense, but more interesting in another. The confusion fades, and a deeper question comes into focus. How does an object move endlessly through space while keeping such a steady posture? Once intuition has been reset in this way, the stage is gently prepared for understanding motion itself. Not hurriedly, not technically, but with the calm recognition that the moon's behaviour is subtle, precise, and shaped by forces that work patiently over time. At first glance, rotation feels like one of the simplest motions to understand. Something spins, and eventually every side comes into view. A turning wheel reveals all its spokes. A rotating globe shows oceans, continents, and then oceans again. Rotation, in everyday life, usually means change that is obvious and unmistakable. This expectation is so deeply ingrained that it quietly shapes how motion is imagined in space. If the moon is rotating, then surely it must be turning its face away at some point. Surely it must be revealing something new. And yet, night after night, it does not. The same features remain in place, as if pinned there. The key to resolving this tension lies in recognizing that rotation alone does not determine what is seen. What matters just as much is how that rotation relates to the observer. It is entirely possible for an object to spin and still keep the same side facing a particular direction. The trick is that the rotation must be matched step for step with another motion happening at the same time. A simple everyday analogy helps here. Imagine walking around a table while keeping your eyes fixed on a cup sitting at its center. As you move, your body rotates. Your feet step in a circle. Your shoulders turn. By the time you've walked all the way around, you have completed a full rotation. Yet the cup has never left your view. You did not turn your back on it even once. You rotated, but your orientation relative to the cup stayed the same. From the outside, someone watching would clearly see rotation. From your perspective, however, nothing appears to turn. The cup remains directly ahead the entire time. This distinction is crucial. Rotation describes motion in space. Orientation describes what faces what. The two are related, but they are not identical. The moon behaves in a similar way. It rotates on its own axis. That rotation is real, measurable, and continuous, but it also travels around Earth at the same time. These two motions are synchronized in such a way that the same surface always points toward the planet beneath. The moon completes one full rotation in exactly the same amount of time it takes to complete one orbit around Earth. As it moves forward along its path, it turns just enough to keep its familiar face aligned. To an observer standing on Earth, this creates the illusion of stillness. The moon seems to slide across the sky without spinning. Its markings remain fixed. Its orientation appears locked in place. But from a different vantage point, the motion is obvious. Viewed from far above the Earth and Moon system, the moon's rotation would be clearly visible. It would be seen turning steadily once per orbit, like a dancer completing a slow, deliberate spin while circling a partner. This highlights an important lesson about motion in general. Whether something appears to move or not depends entirely on where the observer stands. Motion is not absolute, it is relational. Even on Earth, this idea quietly plays out all the time. A person sitting on a train feels still, even as the landscape rushes by. A passenger on a smoothly cruising airplane may forget they're moving at all. The sensation of motion often fades when movement is steady and predictable. The moon's rotation is slow enough, and its synchronization precise enough, that it slips beneath everyday perception. There is no sudden turning, no dramatic reveal, just a quiet consistency maintained over immense time. Another helpful analogy comes from dance. Imagine two partners moving together in a slow waltz. One partner always faces the other, even as both turn around the dance floor. To someone watching from the center, the facing never changes. To someone watching from above, the rotation is unmistakable. The moon and Earth are locked into a similar rhythm. The moon turns, but it turns in time with its orbit. The result is motion that preserves orientation. This can feel counterintuitive because rotation is often imagined as something that inevitably exposes all sides. But that is only true when rotation happens in isolation. When combined with another motion of equal pace, rotation can instead preserve a single view. There's also a tendency to imagine space as a static backdrop, where objects move independently against a fixed grid. In reality, space is relational. Motions are defined by how objects move with respect to one another. For the moon, the most important relationship is with Earth. The moon's orientation is not fixed relative to distant stars. It is fixed relative to the planet it orbits. Over the course of a month, the moon turns fully with respect to the wider universe, even though it keeps the same face toward Earth. This distinction gently prepares intuition for orbital motion. Orbiting is not simply moving around something. It involves constant adjustment of direction. An object in orbit is perpetually falling forward, curving its path to match the pull of gravity. As the Moon travels along this curved path, it must continually adjust its orientation if it wishes to keep the same face pointed inward. That adjustment is achieved through rotation. The two motions are inseparable. There is a quiet elegance in this arrangement. The Moon does not need to correct itself or make active decisions. Once the rhythm is established, the motion sustains itself naturally. Rotation and orbit remain in balance, maintaining orientation without effort. Gentle humour can be found in how deceptive this simplicity is. Something that looks motionless turns out to be spinning steadily. Something that seems obvious turns out to be subtle. The Moon gives the impression of laziness while quietly performing a precise cosmic routine. This understanding helps dissolve the illusion that the Moon is somehow cheating physics. It is not resisting rotation. It is not defying motion. It is participating in it in a very particular way. By separating the idea of spinning from the idea of turning toward or away from an observer, the behaviour of the Moon becomes less puzzling. Rotation does not guarantee variety of view. Orientation depends on context. Once this distinction settles in, the Moon's stillness starts to feel earned rather than strange. The steady face is no longer a mystery, but a consequence of matched motion. And with that comfort established, the mind is ready to think more clearly about how the Moon moves through space at all. Not just how it turns, but how it travels, how it stays in place without standing still, and how gravity quietly guides that motion, moment by moment, along a curved and patient path. It is easy to think of the Moon as a quiet fixture in the sky, something placed there long ago and left to hover peacefully above Earth. It rises, it sets, it repeats. The motion feels gentle enough to ignore, almost decorative. But beneath that calm appearance, the Moon is in constant motion, tracing a smooth and steady path through space. At every moment, the Moon is travelling around Earth, not drifting aimlessly, not wandering off course, but following a well-defined orbit shaped by gravity. This journey is so regular that it blends into the rhythm of nights and days. Because it takes a little under a month to complete one full circuit, the movement unfolds slowly, quietly, without urgency. From the ground, that slowness can be deceptive. A glance at the sky shows the Moon apparently hanging in place, barely shifting its position from one moment to the next. Even over the course of an evening, its motion is subtle enough to escape notice unless attention is held on it for a long time. But slowness does not mean stillness. The Moon is covering vast distances as it moves. Each hour, it travels farther than most people will in their entire lives. The reason this motion feels calm rather than dramatic has everything to do with scale. Distance changes how movement is perceived. A car passing close by feels fast. The same car seen from far away appears to glide gently. A plane overhead seems leisurely, compared to the blur of a bicycle crossing nearby. The Moon is so distant that its speed is softened by perspective. There's also the matter of reference points. On Earth, motion is judged against familiar landmarks. Trees, buildings, mountains. These fixed points make even small movements noticeable. In space, there are no nearby signposts. The Moon moves against a backdrop of stars that are unimaginably distant, making its progress seem even more gradual. This creates an illusion of stillness. The Moon appears serene, almost motionless, even though it is never at rest. Its path curves smoothly around Earth, guided by gravity in a continuous balancing act. An orbit is not a static loop. It is a constant act of falling and missing. The Moon is pulled inward by Earth's gravity, but it also carries forward motion that prevents it from falling straight down. The result is a curved path, a perpetual sideways fall that never quite reaches the ground. This kind of motion is easy to describe but difficult to feel intuitively. Everyday experience rarely involves falling sideways around something, yet this is exactly what the moon is doing, moment after moment, maintaining a stable distance while never standing still. The steadiness of the orbit adds to the sense of calm. There are no sharp turns, no sudden accelerations. The moon does not lurch or wobble in a way that demands attention. Its motion is smooth, predictable, and patient. Over the course of a single night, the moon's movement can be noticed if one is willing to watch carefully. Relative to the stars, it shifts its position slightly, inching eastward. It does not return to the same spot in the sky at the same time each night. Instead, it rises a little later, day after day, quietly signalling its ongoing journey. This gradual shift is one of the few clues available from the ground that the moon is truly in motion. Even then, it is easy to miss. Daily routines pull attention elsewhere. The moon's pace does not compete for notice. There is a gentle humour in how much effort the moon puts into moving while appearing so relaxed. It circles Earth faithfully, maintaining its path with remarkable precision, yet gives the impression of doing almost nothing at all. It is the cosmic equivalent of someone walking steadily for hours while appearing perfectly at ease. The scale of the Earth-Moon system also plays a role in shaping perception. The distance between Earth and the Moon is large enough that changes unfold slowly, but small enough that the relationship feels intimate. The Moon is close enough to feel like a companion, but far enough that its motion feels abstract. This balance makes the Moon uniquely soothing to observe. It moves, but not urgently. It changes position, but not abruptly. It embodies motion without haste. That motion is not isolated. As the Moon orbits Earth, Earth itself is moving as well. Earth travels around the Sun. The Sun moves through the galaxy. The galaxy drifts within the larger structure of the universe. The Moon's gentle orbit is layered atop many other motions, all unfolding simultaneously. From this perspective, stillness becomes a relative concept. Nothing in the universe is truly stationary. What feels still is simply moving in harmony with its surroundings. The Moon appears calm because its motion is steady and consistent relative to Earth. This layered movement deepens the sense of quiet complexity. While the Moon traces its path around Earth, it is also being carried along on a much larger journey. Its orbit is a small loop, embedded within vast cosmic motion. And yet, despite all this movement, the Moon maintains its familiar presence in the sky. It does not wander unpredictably. It does not drift away. It stays close, bound by gravity, moving just enough to maintain balance. This steadiness is essential to understanding why the Moon behaves the way it does. The orbit provides the framework within which rotation and orientation make sense. Without orbital motion, the idea of keeping one face toward Earth would lose its meaning. The Moon's constant travel ensures that rotation is not optional. To remain aligned, the Moon must turn as it moves. The orbit and the rotation are linked, not as separate actions, but as parts of a single, coordinated motion. Recognizing that the Moon is always on the move helps dissolve the illusion of stillness. The familiar face is not the result of inactivity. It is the result of continuous motion carried out with extraordinary consistency. There is something calming about this realization. Motion does not have to be frantic to be meaningful. Change does not need to be dramatic to be real. The Moon demonstrates how much can happen quietly, without spectacle. As it circles Earth, the Moon reminds us that the universe often prefers gentle persistence over sudden shifts. Things move, relationships evolve, patterns emerge, all without demanding tension. The night sky may look peaceful, but it is full of motion layered upon motion, each moving at its own pace. The Moon's orbit is one of the most visible examples of this quiet choreography. Understanding this steady movement sets the scene for a deeper appreciation of how gravity shapes long-term behaviour. The Moon's calm path is not accidental. It is the outcome of forces acting patiently over time, guiding motion into balance. And so the Moon continues its journey, always moving, always circling, always appearing calm, a reminder that slowness can still carry momentum, and that even the quietest objects in the sky are never truly still. The calm, steady Moon seen today gives little hint of how turbulent its beginnings were. It feels permanent, settled, almost timeless. But this peaceful arrangement is the result of an origin story far more energetic than the quiet night sky suggests. In the earliest days of the solar system, nothing was gentle. Planets were still forming, orbits were unstable, worlds collided, merged, and broke apart. Earth itself was not yet the familiar place it would become. It was hotter, faster, and far more chaotic, surrounded by debris left over from planetary construction. The leading explanation for how the Moon formed begins in this restless era. Rather than condensing quietly from leftover material, the Moon is thought to have been born from a colossal impact. A young Earth is believed to have collided with another planetary body, roughly the size of Mars. This object is often given a name in scientific discussions, but the label matters far less than the event itself. The collision was immense, not a gentle bump but a glancing blow that tore material from Earth's outer layers and sent it swirling into space. Rock was vaporized. Molten material was flung outward. A vast disk of debris formed around the damaged planet, glowing with heat and motion. From this disk, over time, material began to clump together. Gravity pulled fragments into larger pieces. Collisions continued, but now on a smaller scale, slowly building a single body. This growing companion would eventually become the Moon. At this stage, nothing about the Earth-Moon relationship was calm. The Moon formed much closer to Earth than it is today. The distance between them was a fraction of what it is now. Earth loomed large in the Moon's sky, dominating it in a way that feels almost unimaginable from the present perspective. Both bodies were rotating rapidly. Earth spun faster than it does now. The Moon spun faster as well. Their gravitational interaction was intense, and the forces between them were strong and constantly changing. The early Moon did not quietly circle Earth in a smooth, predictable path. Its orbit was likely more stretched, more tilted, and more erratic. The system was energetic, filled with motion that had not yet settled into balance. This period of instability is important to remember because it explains why today's arrangement cannot be taken for granted. The Moon was not placed gently into its current role. It earned that position through billions of years of adjustment. In those early days, gravity was already at work, but its influence was not yet subtle. The close proximity between Earth and the Moon meant that gravitational forces were much stronger than they are now. Each body tugged powerfully on the other, raising tides not only in oceans but in solid rock. The Moon, still warm from its formation, was especially vulnerable to these forces. Its shape flexed, its interior experienced stress and heating. Energy was constantly being transferred between motion and internal friction. This exchange of energy is slow by human standards, but relentless over cosmic time. Every tiny flex, every slight distortion, removed a small amount of energy from the system. That energy did not disappear. It was converted into heat, gently warming the Moon's interior. At the same time, Earth was changing too. The early Earth likely experienced stronger tides than it does today. Its rotation gradually slowed as energy was transferred outward. The Moon, meanwhile, began a long journey away from Earth, moving outward as the system adjusted. This outward drift is still happening today, though at a much gentler pace. But in the beginning, the changes were faster, more dramatic, and more consequential. It is tempting to imagine this early era as chaotic in a destructive sense. but there is also order in it. Gravity was already guiding the system towards stability. It was not rushing. It was allowing motion to settle naturally, shedding excess energy over time. The Moon's rotation during this period was not synchronized with its orbit. It spun freely, showing different faces to Earth as it moved. But each rotation created internal stress. Each cycle of stretching and relaxing drained a little energy. Over immense stretches of time this mattered. The Moon slowly lost rotational energy. Its spin began to slow, not abruptly, not noticeably from one moment to the next, but steadily, patiently, guided by gravity's quiet persistence. This process did not aim for a specific outcome. There was no target state. The system simply evolved toward configurations that were more stable, more balanced, and less energetic. The Moon's current behavior is one such configuration. It represents a low-energy state, where motion and orientation are in harmony. But reaching that state required a long journey through instability. There is a subtle lesson here about how calm emerges in the universe. Peaceful arrangements are often the result of energetic beginnings, followed by long periods of adjustment. Stability is not the absence of motion, but the presence of balance. The Moon's early history also helps explain why its surface looks the way it does. Intense heating, volcanic activity, and early impacts shaped the Moon's crust. These processes left marks that are still visible today, frozen into the landscape. Those familiar dark plains and bright highlands are not random decorations. They are records of a time when the Moon was far more active than it appears now. The calm face seen from Earth is a mask shaped by ancient turmoil. There is a gentle humour in how misleading appearances can be. The Moon looks serene, even sleepy, as if it has always been this way. In truth, it carries the scars of a violent youth, worn so quietly that they blend into beauty. Understanding the Moon's unsettled beginnings helps reframe its present stillness. The steady orientation toward Earth is not an original feature. It is the outcome of long-term gravitational influence acting on a system that began in chaos. Gravity does not rush to tidy things up. It works slowly through countless small interactions. It allows energy to drain away, motion to smooth out, and relationships to stabilize. By starting with an energetic origin, the Moon's current behavior becomes more meaningful. The calm seen today is not trivial, it is earned. As the Moon settled into its orbit and its rotation slowed, gravity continued to guide the process. The influence that began in violence gradually transformed into a quiet, shaping force. This shift from chaos to calm sets the stage for understanding how gravity operates over deep time, not as a sudden pull, but as a patient sculptor, shaping motion into balance. The Moon's story begins with upheaval, but it does not end there. From an unsettled beginning emerged one of the most stable relationships in the night sky, a reminder that even in a restless universe, lasting calm can slowly take shape. Gravity is often imagined as a sudden force, something that pulls, tugs, or snaps objects into motion. An apple falls, a stone drops, a planet captures a moon. These moments feel decisive, as if gravity acts quickly and then moves on. But in the story of the Moon, gravity behaves very differently. It is not a single event. It is a conversation that never stops. A quiet exchange that continues moment by moment, shaping motion not through drama, but through patience. Gravity does not switch on and off. It does not wait for the right moment to act. It is always present, always influencing how objects move, even when those movements are too subtle to notice. When nothing seems to be changing, gravity is still at work. The Moon's current calm orbit is a perfect example of this. From night to night, the changes are minimal. The path looks stable. The distance feels constant. But stability does not mean inactivity. It means balance maintained through continuous interaction. Every second, Earth and the Moon pull on each other. This mutual attraction keeps the Moon from drifting away and prevents it from falling inward. The orbit exists because gravity is constantly guiding the Moon's path, curving its motion just enough to maintain the relationship. This guidance does not require adjustment or correction. Once the balance is established, gravity sustains it naturally. The Moon does not need to be nudged back into place. The conversation simply continues. What makes gravity especially interesting in this context is that it does more than hold things together. Over long periods, it also transfers energy, not in dramatic bursts, but in tiny amounts, spread across immense time. To understand this, it helps to think of gravity not as a static glue, but as an active influence that responds to motion. When objects move under gravity, especially when they are close and extended rather than perfectly rigid, subtle distortions occur. Neither Earth nor the Moon is a perfectly solid, unchanging sphere. Both are slightly flexible. They respond to gravitational pull by stretching just a little, changing shape by an amount too small to see, but large enough to matter. These small distortions create internal friction. Materials resist being bent and squeezed. That resistance turns some of the system's energy into heat. The process is slow, but relentless. This is where gravity's long conversation becomes especially meaningful. Each tiny deformation is a syllable. Each release of energy is a pause. Over millions and billions of years, those pauses add up. Energy is not lost in the sense of disappearing. It is transformed. Motion becomes heat. Rotation becomes warmth. The system gradually sheds excess energy, settling into configurations that require less constant adjustment. In the early Earth-Moon system, the energy transfer was much more intense. The two bodies were closer together, and gravity's influence was stronger. Distortions were larger. Friction was greater. Energy flowed more quickly. As the system evolved, the rate of change slowed. The Moon moved farther away. The gravitational pull weakened slightly. The conversation became quieter, but it never stopped. This continuous action helps explain why the Moon's behavior today feels so stable. The system has already given up much of its excess energy. What remains is a balanced state where motion is smooth and predictable. There's a gentle humour in how little this ongoing interaction demands attention. Gravity performs its work without noise, without light, without spectacle. It does not announce its presence. It simply persists. Even when the Moon appears motionless in the sky, gravity is shaping its path. Even when nothing seems to be happening, energy is still being exchanged, just at a pace far below everyday perception. This idea can feel abstract, because human experience is built around change that happens quickly. Gravity's influence on falling objects is immediate. Its influence on planetary systems unfolds across timescales that are difficult to imagine, but the principle is the same. Gravity responds to mass and distance. The difference lies in how long the interaction is allowed to continue. In the Earth-Moon system, gravity has had billions of years to work. That time has allowed small effects to accumulate into significant outcomes. Rotation slowed, orbits adjusted, orientations aligned. This long-term shaping is what makes gravity such a powerful organizer of the universe. It does not need to force objects into place. It simply allows energy to flow until balance is reached. The idea of gravity transferring energy sets the stage for understanding tides. Tides are the visible expression of this energy exchange. They are the surface ripples of a much deeper process. On Earth, tides are most obvious in the oceans. Water rises and falls in response to the Moon's pull, but the same principle applies to solid rock. The ground itself responds, flexing by small amounts as gravity shifts. On the Moon, these effects were once far stronger. The early Moon experienced significant stretching and squeezing as it orbited close to Earth. Each cycle drained a little rotational energy. This slow loss of energy is the reason the Moon's spin changed over time. Gravity did not force the Moon to stop turning. It allowed turning to gradually fade into a rhythm that matched the orbit. This is the heart of gravity's long conversation. Not a command, but a negotiation. Not a sudden grab, but a continuous influence that guides systems toward equilibrium. Understanding gravity in this way helps reframe the Moon's current behavior. The steady orientation toward Earth is not the result of a single event. It is the outcome of countless small interactions, each one contributing a tiny adjustment. There is something quietly reassuring in this process. It suggests that order can emerge without force, that balance can arise without urgency, that patience can shape complexity. As gravity continues its conversation with the Moon, the system remains alive with motion, even in its calmest state. Energy still flows, distances still change, though very slowly. Nothing is frozen. By viewing gravity as a long, ongoing exchange rather than a one-time pull, the Moon story becomes less mysterious and more coherent. The forces at work are gentle, but they are persistent. This understanding opens the door to a deeper exploration of how tides work and how they quietly sculpt both Earth and Moon. Gravity has been speaking all along. It simply speaks in a voice so steady that it often fades into the background. Yet it is this quiet voice that has shaped one of the most familiar relationships in the night sky. A reminder that the universe often does its most important work without raising its voice at all. When the word tides comes up, the mind usually drifts straight to the ocean. Rolling waves, shorelines slowly breathing in and out, the steady rise and fall of water that coastal life has learned to live with. Tides feel like a story written entirely in water. But the ocean is only the most visible expression of a much broader idea. Tides are not limited to seas and shorelines. They are a response to gravity itself. Wherever gravity acts unevenly across an object, tides appear. This uneven pull is subtle but powerful. Gravity is stronger on the side of an object closer to what is pulling it, and slightly weaker on the far side. The difference is small, but it matters. It creates a gentle stretching effect, tugging at material from multiple directions at once. On Earth, water responds easily to this stretching. It flows, bulges, and shifts with little resistance. That is why ocean tides are so obvious. They move freely, reshaping coastlines twice a day. Solid rock, however, seems like it should be immune. Rock feels rigid. It feels permanent. It feels like the opposite of something that could stretch. And yet, even solid bodies respond to tidal forces. Earth's surface rises and falls by small amounts as the Moon passes overhead. The ground itself flexes, lifting and settling in slow rhythm. This movement is far too small to feel, and far too slow to notice without instruments. But it is real. The Moon experiences similar effects, though in its early history those effects were much stronger. When the Moon was closer to Earth, gravity's uneven pull was more intense. The Moon's shape was gently distorted over and over again as it orbited. Imagine holding a soft rubber ball and squeezing it slightly, then releasing it, then squeezing again. Each time, the ball changes shape, then returns to something close to its original form. Now imagine doing that slowly, repeatedly, for millions of years. That is roughly what gravity was doing to the Moon. The Moon was never squashed dramatically. There were no visible dents or sudden collapses. The stretching was subtle, almost imperceptible at any given moment. But subtle does not mean insignificant. Every time the Moon flexed, its internal material resisted that change. Rock does not like to be bent. It pushes back. That resistance creates internal friction. Friction is often associated with surfaces rubbing together, hands warming when rubbed, tyres gripping the road. But friction also exists within materials themselves. When something is bent, twisted or stretched, its internal structure shifts slightly. That shifting generates heat. Inside the moon, these repeated flexing motions produced warmth, not enough to glow or melt everything at once, but enough to slowly convert motion into heat. This conversion is the key. Energy stored in rotation and movement was gradually being transformed into thermal energy inside the moon. The moon was, in a very quiet way, warming itself through gravitational interaction. This process did not happen evenly. The amount of flexing depended on the moon's orientation, its distance from Earth, and how fast it was rotating. As the moon spun, different regions experienced slightly different stresses. Over time, these stresses acted like a brake, not a sudden stop but a gentle resistance. Each flex took a tiny bite out of the moon's rotational energy. The idea of rock flexing can feel strange, because everyday experience suggests solidity is absolute. But on planetary scales, even stone behaves more like a very thick fluid. Given enough force and enough time, it flows. Mountains slowly sink. Crusts rise and fall. Entire worlds respond to gravity with a kind of slow-motion elasticity. There is something quietly amusing about this. The moon, which looks like a solid, unchanging disk in the sky, was once being gently kneaded by gravity like dough that was not quite ready to rest. The important thing to remember is that this flexing was not destructive. It was transformative. It allowed energy to move from one form to another, guiding the system toward a more stable state. As rotational energy drained away, the moon's spin began to slow, not noticeably from one year to the next, or even from one century to the next. The change was far too gradual for that, but across millions and billions of years the effect was profound. The moon did not need to lose all its rotation. It only needed to lose enough to fall into a rhythm that minimized further stress, a state where flexing was reduced and energy loss slowed dramatically. That state would come later. But the groundwork was laid during this long period of tidal interaction. On Earth, a similar process continues today, though at a much gentler pace. Earth's rotation is slowly slowing down. Days are lengthening, though by amounts too small to notice without precise measurements. Again, the mechanism is internal friction. Ocean tides rub against the seafloor. Land tides flex the crust. Energy is transferred outward to the moon, nudging it farther away. This exchange is ongoing. It did not end when the moon settled into its familiar behavior. It simply became quieter. Understanding tides beyond the ocean reframes gravity's role in shaping worlds. Gravity does not just pull objects together, it deforms them, it kneads them, it encourages motion to change character over time. The moon's early experience with strong tidal forces explains why its rotation changed so dramatically. It was not forced into stillness, it was slowly persuaded into balance. This idea prepares the mind for the next step in the story. Once internal friction begins to drain energy, change becomes inevitable. Motion seeks paths of least resistance. Systems evolve towards states that demand less constant adjustment. The moon's gradual slowing was not a flaw or a failure. It was a natural response to repeated flexing under gravity's influence. By expanding the idea of tides beyond water, the moon's behavior starts to feel less mysterious and more organic. The same principles that raise oceans also shape planets and moons. They simply do so on timescales that stretch far beyond everyday experience. In the quiet dark of space, gravity continued its steady conversation with the moon, stretching, releasing and warming it ever so slightly. Each cycle carried away a bit of motion, guiding the moon toward a calmer state. This slow surrender of energy set the stage for one of the most stable arrangements in the night sky, a rotation that slowed just enough, an orbit that adjusted just right, a relationship that would eventually feel timeless. All of it began with tides, not just in water, but in stone. Motion is often imagined as something that ends suddenly. A spinning top wobbles, slows, and then stops. A thrown ball arcs through the air and comes to rest. In everyday life, movement tends to feel temporary, something that fades quickly once energy runs out. But on planetary scales, motion behaves very differently. It does not rush toward an ending. It eases into new forms. It sheds energy gradually, almost reluctantly, over spans of time that are difficult to hold in mind. The moon's rotation is a perfect example of this slower kind of change. It didn't stop spinning in a dramatic moment. There was no final turn, no instant when motion ceased and stillness took over. Instead, its rotation softened little by little, stretched across an almost unimaginable length of time. In its early history, the moon rotated much faster than it does today. Days on the moon were shorter. Sunlight swept across its surface more quickly. But gravity, working through tides and internal friction, began to take small amounts of energy from that rotation. Each tiny loss mattered, not because it was noticeable, but because it was repeated over and over again. This is one of the most important ideas to settle into. Motion does not need to be dramatic to change. It only needs a gentle influence applied consistently. Every time the moon flexed under Earth's gravitational pull, a little rotational energy was converted into heat. The moon warmed slightly inside. The spin slowed by an amount too small to measure in a single lifetime, or even many lifetimes. But the universe is patient. Over millions of years, those tiny changes accumulated. Over billions of years, they reshaped the moon's behavior completely. What began as a freely spinning body gradually became something more restrained, more orderly. There is a tendency to underestimate how powerful time can be. Human intuition is built around short durations, days, years, perhaps decades. Beyond that, changes feel abstract. But gravity has no such limitation. It works just as comfortably across 1 billion years as it does across a single second. This is why the moon's slowing feels so effortless in retrospect. There was no resistance to overcome all at once. No need for a sudden event. Gravity simply continued doing what it had always done, letting energy drain away at a steady pace. The moon did not notice this process. There was no moment of awareness, no point at which it could be said that the rotation had meaningfully changed. The shift was smooth, continuous, and unbroken. From the outside, the result looks dramatic. A world that once spun freely now keeps one face turned toward Earth. But the path between those states was gentle. This gradual slowing also explains why the moon did not overshoot into complete stillness. Motion rarely vanishes entirely. Instead, it settles into patterns that minimize further energy loss. As the moon's rotation slowed, the stresses caused by tidal flexing changed. Some orientations produce more internal strain than others. Certain rhythms allowed the moon to flex less, generating less heat and losing less energy. Over time, the moon naturally drifted toward one of these low-stress states, a configuration where the same side faced Earth, reducing internal distortion. Once this arrangement was reached, the rate of energy loss dropped dramatically. This is a common theme in physics. Systems tend to evolve towards states that are easier to maintain, not because they aim to, but because those states simply persist longer. The moon's current rotation is one such state. It is not motionless. It is rotating steadily, but it does so in a way that produces minimal internal friction. This balance took an extraordinary amount of time to establish. Estimates suggest that the process unfolded over billions of years, long enough for continents on Earth to shift, long enough for life to emerge, evolve and diversify, long enough for countless nights to pass beneath a slowly changing sky. During all that time, the moon continued to lose energy, imperceptibly but relentlessly. Each orbit shaved off a fraction of its rotational speed. Each flex nudged it closer to its present rhythm. There is something quietly humbling about this. A process so slow that it dwarfs human history can still have a decisive outcome. The moon's familiar behavior is the result of patience on a cosmic scale. Gentle humor can be found in how easily this patience is overlooked. It is tempting to ask when exactly the moon locked into its current orientation, as if there were a specific date to mark on a calendar, but the truth is far less tidy. There was no single moment, no cosmic announcement, no dramatic before and after. The change was continuous, blending seamlessly from one state to the next. Even today, the process is not entirely finished. The moon continues to move away from Earth. Very slowly. Earth's rotation continues to slow, very slightly. The conversation between them has not ended. It has simply become quieter. This ongoing change reinforces an important point. Stability does not mean stagnation. The system is still evolving, just at a pace that feels static to human senses. Understanding this helps reframe how motion is perceived in the universe. Things rarely stop, they transition, they exchange energy, they settle into new patterns. The moon's rotation did not vanish, it was reshaped. Patience, then, is not just a theme of this story, it is the mechanism by which the story unfolds. Gravity does not hurry, it allows time to do the heavy lifting. This perspective can be oddly comforting. It suggests that large changes do not always require force or urgency. Sometimes they require only consistency. The moon's journey from rapid rotation to gentle synchrony is a testament to this idea, a reminder that the universe often favors slow solutions. As the moon lost energy, it did not become weaker. It became more stable, less stressed, more settled into its role. That settling process is what made the moon's behavior predictable enough to become part of human experience. The same face rising night after night is not an accident. It is the visible result of a very long history of energy loss managed with extraordinary patience. When viewed through this lens, the moon's stillness feels less like an absence of motion and more like a refined form of it. Motion that has been shaped, smoothed, and disciplined by time. The idea that something can lose energy without stopping entirely is central to understanding not just the moon, but many processes throughout the universe. Stars evolve this way. Orbits shift this way. Systems age gracefully, trading excess energy for balance. By appreciating how slowly the moon's rotation changed, the scale of the universe becomes clearer. Processes that feel eternal are often simply very patient, and as the moon continues its quiet journey around Earth, rotating just enough to keep its familiar face in place, it carries with it the lesson that change does not have to be loud to be profound. At some point in the moon's long history, something subtle but important happened. The gradual slowing of its rotation reached a point where motion began to repeat itself in a very particular way. Not abruptly, not dramatically, but with a kind of quiet inevitability. This state is known as tidal locking, though the name can sound more mechanical than the reality. It suggests something snapping into place, as if a cosmic latch suddenly clicked shut. In truth, nothing of the sort occurred. There was no lock being thrown, no instant of capture. Instead, motion simply fell into rhythm. Tidal locking describes a situation where a rotating body turns at exactly the same pace as it travels around its partner. One full rotation takes precisely as long as one full orbit. The result is a steady alignment. The same side continues to face inward, not because it must, but because the timing works out that way. For the Moon, this meant that every time it completed a journey around Earth, it had also completed one slow turn on its own axis. The turning did not stop. It just became synchronized. A useful way to picture this is to imagine walking around a campfire while always facing the flames. Each step forward requires a slight turn of the body. By the time a full circle is completed, a full rotation has happened as well. From the fire's point of view, the same face was visible the entire time. Nothing is frozen in that motion. It is smooth and continuous. It simply repeats. The Moon reached a similar arrangement through gradual adjustment. As its rotation slowed, there came a point where one spin per orbit minimized internal stress. In that orientation, the constant flexing caused by gravity was reduced. Less flexing meant less internal friction. Less friction meant less energy loss. This was a comfortable configuration. Once reached, it tended to persist. The idea of comfort may sound strange when applied to a celestial body, but it is a helpful metaphor. Physical systems naturally drift towards states that are easier to maintain, not because they choose to, but because those states waste less energy. Before tidal locking, the Moon experienced varying degrees of stress depending on how fast it was spinning. Some rotational speeds caused more stretching than others. Those speeds led to greater energy loss and faded away more quickly. Eventually, the rotation rate that matched the orbital period stood out as especially stable. In that rhythm, the Moon flexed less. Heat generation dropped. Change slowed to a crawl. Once the Moon settled into this pattern, it had little reason to leave it. Any small deviation would increase internal stress again, gently nudging the system back toward alignment. This is why tidal locking feels permanent, even though it is not enforced by any rigid rule. It is self-maintaining. Like a pendulum resting at the lowest point of its swing, the system naturally stays where energy loss is minimal. Importantly, this process did not require precise timing from the beginning. The Moon did not need to aim for one rotation per orbit. Gravity simply allowed energy to drain away until this balance emerged on its own. This makes tidal locking feel less like a special trick and more like a common outcome. Given enough time, many moons end up in similar arrangements. In fact, throughout the solar system, tidal locking is more the rule than the exception. Many large moons always show the same face to the planets they orbit. The phenomenon is widespread, not rare. What makes the Moon feel special is not that it is tidally locked, but that it is close enough and large enough for the effect to be obvious from Earth. It is familiar. It fills the sky. Its steady orientation becomes part of daily experience. There's also a tendency to imagine tidal locking as a kind of endpoint, as if motion has reached its conclusion. But that framing misses something important. The Moon did not stop moving when it became locked. Its motion became orderly. The Moon still rotates. It still orbits. It still travels through space at great speed. The difference is that these motions now share a common rhythm. This shared rhythm creates the illusion of stillness. The same face remains in view, so nothing appears to turn. But beneath that calm appearance, movement continues uninterrupted. This balance between motion and repetition is one of the quiet wonders of orbital mechanics. It shows how complexity can resolve into simplicity without losing its dynamic nature. There is a gentle humour in how easily this balance is misinterpreted. The Moon appears stubborn, as if refusing to turn around. In reality, it is turning constantly, just politely keeping the same side forward. The locking itself did not happen overnight. It unfolded over immense stretches of time, long before humans existed, long before Earth looked anything like it does now. The moon's rotation slowed gradually until the rhythms matched, and then continued almost unchanged. This long settling period reinforces an important idea. Stability in the universe often emerges slowly. Dramatic events may start processes, but quiet persistence finishes them. Once tidal locking was established, the moon entered a phase of relative calm. Energy loss continued, but at a much reduced rate. The conversation between Earth and Moon softened. Change did not stop, but it became subtle. This is why the Moon's orientation feels timeless. The arrangement has been stable for so long that it feels like a permanent feature of the world, yet it is the result of motion, not the absence of it. Understanding tidal locking in this way helps remove any sense of mystery or exception. The Moon is not behaving oddly, it is behaving naturally. Given gravity, time, and a close relationship between two bodies, this outcome is expected. The Moon simply had enough time for the process to run its course. The idea that one rotation came to match one orbit might sound precise, even delicate, but it didn't require perfect tuning. The system naturally gravitated toward that match because it was energetically favourable. Once there, it stayed. This rhythm also explains why the Moon does not drift randomly in orientation over time. Any attempt to rotate faster or slower would reintroduce stress. Gravity would gently resist that change, guiding the system back toward balance. In this sense, tidal locking is not a trap. It is a resting place. Motion falls into rhythm, energy loss slows, the system breathes easily. By seeing tidal locking as a natural settling rather than a sudden capture, the Moon's behaviour becomes less puzzling and more graceful. It is the result of patience rewarded. The Moon did not freeze in place. It learned a rhythm and kept it. And that rhythm, repeated faithfully for billions of years, is what allows one familiar face to rise night after night, steady and unchanged, even as the Moon continues its quiet journey through space. Once the Moon settled into its steady rhythm, it might seem reasonable to expect Earth to do the same. After all, gravity works both ways. The Moon pulls on Earth just as Earth pulls on the Moon. If one body slowed and aligned, why did the other not follow suit? The answer lies not in a single reason, but in a collection of differences that add up over time. Earth and the Moon are partners, but they are very different partners, with very different amounts of energy to manage. The most obvious difference is size. Earth is far larger and far more massive than the Moon. With that mass comes momentum. A heavier object resists changes to its motion more strongly than a lighter one. Slowing Earth's rotation is a much bigger task than slowing the Moon's. In its early history, Earth was spinning rapidly. Days were shorter. The planet carried enormous rotational energy. Gravity could influence that energy, but it would take far longer to drain it away. The Moon, by contrast, was smaller and more easily shaped by gravitational forces. Its rotation was easier to slow. Its internal structure responded more readily to repeated flexing. The same process that gently guided the Moon toward tidal locking worked on Earth too, but at a very different pace. Mass is only part of the story. Earth's internal structure also plays an important role. Earth is layered, with a molten outer core, a solid inner core, and a crust that floats atop slowly moving rock. This complex interior affects how energy moves and dissipates. But the most important difference, and perhaps the most familiar one, is water. Earth's oceans are not just scenic features. They're dynamic, restless, and deeply involved in how Earth responds to gravity. When the Moon pulls on Earth, the oceans respond dramatically, flowing across the surface in rising and falling tides. These moving waters act like a brake on Earth's rotation. As tidal bulges are dragged slightly ahead of the Moon by Earth's faster spin, gravity pulls back on them. That interaction transfers energy from Earth's rotation to the Moon's orbit. This process is real and ongoing. Earth's rotation is slowing very gradually. Days are getting longer, though by an amount so small it escapes everyday notice. But the presence of oceans also complicates the path toward tidal locking. Water is mobile, it sloshes, shifts, and dissipates energy in messy, variable ways. The tides do not rise and fall smoothly everywhere at once. Coastlines, seafloors, and continents interfere. This complexity spreads out the energy loss. Instead of allowing Earth to settle neatly into a simple rhythm, the oceans create turbulence, friction, and irregularity. Energy is lost, but not in a way that neatly synchronizes rotation and orbit. The Moon, lacking oceans, had a simpler path. Its solid body flexed in response to gravity in a more uniform way. Internal friction acted consistently. The system could find a stable rhythm more easily. There is also the matter of distance. The Moon orbits Earth, but Earth does not orbit the Moon in the same sense. While both bodies technically move around a shared centre of mass, that point lies deep within Earth itself. This asymmetry matters. The Moon's motion is dominated by Earth's gravity. Earth's motion is only slightly influenced by the Moon. The gravitational dance is unequal, and that inequality shapes the outcome. Tidal locking is most effective when one body strongly dominates the gravitational relationship. The Moon fits that role perfectly. Earth does not. Energy flows unevenly in this system. The Moon gave up rotational energy and moved outward. Earth gave up rotational energy as well, but because of its greater mass, the effect was spread thinly across a much larger reservoir of motion. Over billions of years, Earth's rotation has slowed, but it remains far from locking its face toward the Moon. That outcome would require an extraordinary amount of additional time. In fact, if nothing else changed, Earth could eventually become tidally locked to the Moon. But the timeline stretches far beyond the Sun's expected lifespan. Long before that could happen, other processes will intervene. This highlights an important point. Tidal locking is not guaranteed. It depends on mass, distance, internal structure, and time. The Moon had the right combination of factors. Earth did not. This difference broadens the understanding of planetary variety. Not all worlds respond to gravity in the same way. The same forces can produce different outcomes depending on the conditions. Some planets spin rapidly and never lock to their moons. Some moons lock quickly. Some worlds are locked to their stars. Others remain free to rotate. There is no single template. Gravity offers possibilities, not prescriptions. Earth's continued rotation is also essential to life as it exists today. The cycle of day and night drives weather, climate, and biological rhythms. The fact that Earth did not lock to the Moon preserved this variability. There is a quiet balance in how this turned out. The Moon became stable enough to be a reliable presence in the sky. Earth remained dynamic enough to support complexity on its surface. Gentle humour can be found in how unfair this might seem. The Moon had to slow down and behave. Earth got to keep spinning, oceans and all. But this unevenness is precisely what makes planetary systems interesting. The lack of symmetry reminds us that gravity does not enforce identical outcomes. It responds to context. It negotiates differently with different partners. Looking beyond Earth and Moon, this diversity becomes even clearer. Some moons in the solar system are locked so tightly that one side never sees their planet at all. Some planets rotate so slowly that a single day lasts longer than a year. Others spin wildly, tipped on their sides. These variations are not mistakes. They are records of history. Each world carries the imprint of its past interactions, its collisions, its distances, and its internal makeup. Earth's resistance to tidal locking is not defiance. It is the natural result of being larger, wetter, and more energetically complex. Understanding this difference helps prevent a common misunderstanding. The Moon's behaviour is not something Earth failed to copy. It is something Earth was never destined to mirror in the same way. The Earth-Moon system is a partnership, but not a mirror. Each body responded to gravity according to its own nature. Earth continues to spin. The Moon continues to keep its face turned inward. Together they maintain a relationship shaped by imbalance, variety, and time. That imbalance is not a flaw. It is the reason the system works as it does. A steady Moon, a rotating Earth, oceans that move, days that pass. Gravity shaped both worlds, but it did not demand they end up the same. And in that difference lies a deeper appreciation of how varied and flexible planetary systems can be, even when governed by the same quiet, persistent force. At first glance, the Moon appears uniform, a pale disk marked with darker patches and lighter scars. Familiar enough that its features have names passed down through centuries. Seas, highlands, bays, and craters, all visible from Earth without any need to imagine what lies beyond. But this familiarity hides an important truth. The Moon has two very different faces, shaped by very different histories. The side that always faces Earth, known as the near side, looks smoother and darker in many places. Broad, flat plains spread across it, forming the dark shapes that have inspired stories and patterns for generations. These regions are calm in appearance, gently rolling, and relatively free of towering relief. The far side tells a different story. When humanity first saw it, the surprise was immediate. Instead of wide, dark plains, the far side is dominated by bright, rugged highlands. It is densely covered in craters, layered upon craters with far fewer smooth regions to soften the view. These two faces belong to the same Moon, yet they feel almost like different worlds. The contrast is not subtle. The near side is marked by vast areas of solidified lava, known as lunar plains. The far side has very few of these features. Instead, it preserves a more ancient, heavily battered surface. The reason for this difference is not chance, and it is not because one side was protected from impacts. Both sides of the Moon were exposed to the same bombardment from asteroids and debris in the early solar system. Impacts alone cannot explain the contrast. The key lies beneath the surface, in the Moon's volcanic past. Early in its history, the Moon was much hotter than it is today. Heat left over from its formation, combined with energy generated by tidal flexing, kept parts of its interior partially molten. This allowed volcanic activity to occur. When large impacts struck the near side, they fractured the crust deeply. Molten rock from below was able to rise up through these cracks, spreading across the surface and filling large basins. Over time, these lava flows cooled and solidified, creating the smooth plains visible today. On the far side, the crust was thicker. Molten material had a harder time reaching the surface. Even when impacts created large basins, there was less volcanic flooding to fill them in. The result was a surface that remained rougher and more heavily cratered. This difference in crust thickness did not arise randomly. It is closely tied to the Moon's long relationship with Earth. When the Moon was young and still cooling, Earth loomed large in its sky. The side facing Earth experienced stronger gravitational influence and more intense heating from tidal forces. This additional energy helped keep the near side warmer for longer. A warmer interior meant thinner crust. Thinner crust meant lava could escape more easily. Over millions of years, this difference compounded, shaping two distinct faces. Gravity and time work together to write this contrast into the Moon's surface. The near side, warmed and flexed, became more volcanically active. The far side, cooler and more rigid, preserved its ancient scars. This is why the moon's familiar face looks gentler, not because it was spared, but because it was reshaped. There is something quietly poetic about this outcome. The side of the moon that Earth has always seen is also the side that was most influenced by Earth's presence. Gravity did not just lock the moon's orientation, it helped shape its geology. The far side, unseen for most of human history, carries a record of deeper time. Its craters remain crisp and numerous, telling a story of impacts largely unmodified by later volcanic smoothing. Gentle humour can be found in how misleading appearances can be. The side of the moon that looks calmer has actually lived a more dramatic internal life. The rougher side is, in some sense, more pristine. These differences also help explain why the moon feels so familiar from Earth. The smooth planes reflect light differently, creating patterns that are easy for the human eye to recognize. Faces, animals, and symbols emerge naturally from these broad shapes. Had the far side faced Earth instead, the moon might have seemed harsher and less readable. Fewer dark planes would mean fewer bold patterns. The moon might have felt more distant, more abstract. This contrast reminds us that what is familiar is often shaped by perspective. Earth's gravitational influence did not just determine which side of the moon is visible. It helped determine what that visible side looks like. Time played an essential role as well. Volcanic activity on the moon did not last forever. As the moon cooled and lost internal heat, lava flows slowed and eventually stopped. The surface became geologically quiet. By the time volcanic activity ended, the near side had already been reshaped. The far side remained largely unchanged. The difference was locked in place, preserved across billions of years. Today, both sides are inactive. The moon is geologically quiet, with no flowing lava and no active plate movement. What remains is a fossil record written in rock. Each crater marks an ancient impact. Each smooth plane marks a past eruption. Together, they tell a story of how gravity, heat, and time interact to shape worlds. The fact that these differences exist at all is a reminder that tidal locking does more than control orientation. It influences how energy is distributed within a body. It affects where heat lingers and where it escapes. The moon's geology is not evenly spread because gravity was not evenly applied. The near side lived under Earth's constant influence. The far side lived without it. This does not mean the far side is less important. In many ways, it offers a clearer window into the moon's earliest history. Its surface preserves conditions closer to those that existed shortly after formation. The near side, shaped and resurfaced, tells a story of interaction. The far side tells a story of endurance. Together they form a complete picture. A single world with two complementary histories, both shaped by the same forces acting in different ways. Understanding this helps deepen appreciation for why the moon looks the way it does. The familiar face is not just a coincidence of orientation. It is the result of billions of years of gravitational influence and geological response. Gravity did not merely guide the moon's motion, it helped sculpt its surface, subtly favouring one side over the other. Time then froze that difference in place, allowing it to be seen night after night, unchanged. The moon's two sides are not a mystery of darkness and light. They are a record of history and influence, a reminder that even a world that appears still carries a complex past written quietly into its surface. One face smoothened by ancient fire, the other scarred by time, both shaped by gravity's long conversation, carried out patiently across the deepest stretches of cosmic time. The moon's steady presence in the sky offers more than a familiar sight. It provides Earth with something less obvious, but deeply important: stability. Not dramatic control or rigid order, but a gentle consistency that unfolds night after night, century after century. Because the moon is tidally locked, Its position relative to Earth changes very little over time. It does not wander unpredictably across the sky. It does not suddenly flip or drift into strange orientations. Its path is regular, its behavior reliable. This reliability has quietly shaped how life on Earth experiences time. From the earliest days of human observation, the Moon offered a dependable rhythm. Its phases repeated with reassuring regularity. Full, then fading. New, then growing. A cycle that could be counted, anticipated, and trusted. Long before clocks and calendars, the Moon provided a natural measure of passing days. This predictability is not accidental. It emerges directly from the Moon's stable orbit and synchronized rotation. Because the same face always points inward, the Moon's motion is smooth and orderly. The cycles repeat without sudden surprises. That regularity extends beyond appearance. The Moon's gravitational influence creates tides on Earth that follow a steady schedule. Coastal waters rise and fall in a rhythm that can be predicted far in advance. These tides do not wander chaotically. They follow patterns shaped by the Moon's consistent motion. Even inland, where the oceans feel distant, these rhythms matter. They influence currents, ecosystems, and long-term climate patterns. The Moon's steady pull provides a background beat to Earth's natural systems. There is something quietly comforting about this. In a world where weather changes daily and landscapes shift over time, the Moon's cycles offer reassurance. They're slow enough to feel calm, but reliable enough to feel meaningful. Beyond these visible rhythms, the Moon also plays a subtler role in Earth's long-term behavior. Its gravitational interaction continues to influence Earth's rotation, ever so gently. Earth spins faster than the Moon orbits. Because of this, tidal bulges raised by the Moon are carried slightly ahead of the Moon's position. Gravity then pulls back on those bulges, creating a small drag on Earth's rotation. The effect is tiny but persistent. Over time, Earth's spin slows. Days lengthen, not by minutes or seconds, but by fractions so small they require careful measurement. This slowing has been happening for billions of years. In Earth's early history, days were much shorter. The planet rotated more quickly beneath the Sun. As time passed, the Moon quietly drew some of that energy away. This process is still ongoing. Earth continues to lose rotational energy. The Moon continues to drift outward, gaining orbital energy in return. It is a slow exchange, balanced and continuous. Here again, patience is key. The changes are not noticeable on human timescales. No one feels the day lengthening from one year to the next. But over geological time, the effect is profound. This gradual slowing has helped shape Earth's climate and biological rhythms. Longer days influence temperature cycles. Stable rotation supports predictable patterns of light and darkness. Life evolved under these conditions, adapting to a world where day and night followed a reliable cadence. The Moon's role as a stabilizer extends even further. Its gravitational presence helps steady Earth's tilt. The angle at which Earth leans as it orbits the Sun affects seasons. Without the Moon, that tilt could vary more dramatically. Large swings in tilt would create extreme climate changes. Seasons could become chaotic, shifting unpredictably over time. The Moon's steady pull helps dampen these variations, keeping Earth's tilt within a relatively narrow range. This stabilizing influence is subtle but powerful. It does not eliminate change. Seasons still come and go, climate still evolves. But the range of variation remains manageable. There is gentle humour in how understated this role is. The Moon looks decorative, even poetic, hanging in the sky like a quiet ornament. Yet behind the scenes, it is acting as a gravitational anchor, helping keep Earth's behaviour within familiar bounds. The arrangement also benefits human perception. The moon's predictable motion allows eclipses to be anticipated centuries in advance. It allows calendars to be constructed. It allows nights to be planned around moonlight. Even cultural practices reflect this stability. Festivals, rituals, and traditions tied to lunar phases depend on the moon's reliability. The same face rising night after night reinforces a sense of continuity. It is important to note that the moon does not control Earth in a rigid way. Its influence is gentle, not commanding. It nudges rather than dictates. The stability it provides emerges from balance, not force. This balance could only arise because the moon settled into its current rhythm. Had the moon continued spinning freely, or wandered unpredictably, the Earth-Moon relationship would be less orderly. The cycles would be less reliable, the stabilizing effect weaker. The moon's locked orientation ensures that its gravitational pull remains consistent over time. This consistency is what allows long-term patterns to form. There is something deeply reassuring about knowing that one of the most visible objects in the sky is also one of the most dependable. The moon does not surprise. It does not demand attention. It simply does its work quietly. This quiet support often goes unnoticed. People admire the moon for its beauty, its light, its symbolism. Rarely is it appreciated for its steadiness. Yet steadiness is precisely what makes it valuable. The moon's presence smooths extremes rather than creating them. It softens variation rather than amplifying it. It acts not as a ruler, but as a stabilizing partner. In this way, the moon contributes to Earth's long-term habitability. It helps maintain conditions under which complex systems can develop and persist. There is no single moment when the moon began performing this role. It emerged gradually as the Earth-Moon system evolved. As the moon locked into its rhythm and moved outward, its stabilizing influence took shape. This gradual emergence mirrors the way many important processes in the universe unfold. Nothing announces itself as essential. Importance is often revealed only in hindsight. The moon's arrangement offers Earth a quiet gift: predictability, rhythm, stability. Night after night, the same face rises. Tides follow familiar patterns. Days lengthen at a glacial pace. Seasons remain within recognizable bounds. All of this happens without spectacle, without effort, without urgency. The moon does not dominate Earth's behavior. It supports it, and in that quiet support it becomes one of the most influential companions Earth has ever known. For most of human history, the far side of the moon existed only as an idea. It was known to be there in principle, but never seen. A hidden hemisphere that followed the moon faithfully through the sky, always turned away, never offering even a glimpse of its surface. Maps ended at the familiar edge, stories filled in the rest. This absence was not mysterious in a dramatic sense. Astronomers understood why the same face always pointed toward Earth. The geometry was clear, the physics was sound, and yet there was still something quietly unsettling about never having seen the other half of a world so close by. The moon felt intimate, almost domestic, and yet half of it remained entirely unobserved. That changed in the middle of the 20th century, when technology finally allowed machines to go where human eyes could not. In 1959, a spacecraft was sent on a looping path around the moon, carrying cameras designed to take photographs as it passed behind the familiar face. For the first time, images of the far side were captured and transmitted back to Earth. The moment itself was not theatrical. There was no live broadcast, no dramatic reveal unfolding in real time. The data arrived slowly, imperfectly, as strips of images that had to be assembled and interpreted. But the significance was immense. Humanity was seeing the unseen. What emerged from those early images was unexpected. not because the far side was strange, but because it was different in a very specific way. Instead of the broad dark plains that dominate the near side, the far side appeared brighter, rougher, and far more densely cratered. The familiar dark patches were largely absent. This contrast immediately raised questions. The moon was one object. It had formed as a single body. Why would one hemisphere look so unlike the other? Before these images, it was reasonable to assume that the far side would resemble the near side, simply unseen. After all, both sides had faced the same space environment, endured the same bombardment of impacts, and existed under the same physical laws. Symmetry felt like the natural expectation. But the photographs suggested otherwise. The far side looked older, more scarred, and less smoothed by volcanic activity. The surface appeared to preserve a deeper record of early impacts, as if it had been left untouched while the near side was reshaped. This was not a disappointment, it was an invitation. The new view refined scientific understanding rather than overturning it. The basic picture of how the moon moves, rotates, and interacts with Earth remained intact. What changed was the appreciation of how deeply gravity and time had influenced the moon's internal history. The lack of large, smooth plains on the far side hinted at differences beneath the surface. It suggested variations in crust thickness and internal temperature that had persisted long enough to shape the landscape. The moon was not uniform inside, its history was written unevenly. As more missions followed, the picture became clearer. Better images confirm that the far side's crust was thicker on average, making it harder for molten rock to reach the surface in the moon's earlier, hotter days. Volcanic flooding that smoothed the near side had fewer opportunities to occur on the far side. This understanding fit naturally with what was already known about the moon's tidal history. The side facing Earth had experienced stronger gravitational interaction and more prolonged internal heating. The far side, shielded from that influence, cooled differently. In this way, the first glimpses of the far side did not create a new mystery. They resolved an old one by adding missing information. The moon became more complete, not more confusing. There is something quietly satisfying about this kind of discovery. Nothing dramatic was hiding there, no unexpected structures, no fundamental challenge to physics. Just a surface that made sense once the full context was available. Gentle humour can be found in how human imagination had filled the gap. The far side was often portrayed as darker, stranger, even ominous. In reality, it turned out to be brighter and more heavily cratered, almost the opposite of the popular image. The phrase dark side of the moon lingered, even as it became increasingly inaccurate. Light falls on both sides equally over time. What differed was not illumination, but history. These early images also marked a shift in how the moon was understood culturally. It was no longer a half-known object. It became a fully mapped world, with a far side that could be studied, named, and explored, even if it remained out of direct view from Earth. The moon did not lose its sense of mystery. Instead, that mystery changed character. It moved from the question of what was there, to the question of why it was the way it was. This shift is common in science. Discovery rarely closes curiosity, it redirects it. As knowledge of the far side grew, scientists began to see the moon as a record keeper. Its surface preserved evidence of processes that had long since faded elsewhere. Without atmosphere, weather, or active geology, the moon held on to its scars. The far side, in particular, offered a clearer view of early solar system history. Its cratered surface provided insight into ancient impact rates and the environment in which the planets formed. In this sense, the far side was not just different, it was valuable. And yet, despite all this new information, the moon's behaviour in the sky did not change. It continued to present the same face, night after night. The far side remained hidden from casual view, even as it became well known in scientific detail. This contrast highlights an important theme. Visibility and understanding are not the same thing. Something can be unseen and yet deeply understood. Something can be visible and still misunderstood. The moon's far side taught this lesson gently. It showed that the limits of observation can be overcome without drama, and that new knowledge can integrate smoothly into existing frameworks. The first glimpses did not disrupt the moon's role as a calm presence in the night sky. If anything, they enhanced it. Knowing that there is more beyond what is seen adds depth without demanding attention. Even now, when images of the far side are readily available, it retains a sense of quiet distance. It is known, but not experienced directly. It exists as part of the moon's story, rather than part of daily life. This balance suits the moon well. It remains familiar without being fully exposed. It offers completeness without losing intimacy. The moment humanity first saw the far side did not mark an end. It marked a transition from partial knowledge to fuller understanding, a subtle widening of perspective. The moon did not become less mysterious. It became more coherent. By revealing its hidden face, the moon reminded humanity that understanding often arrives not as a shock, but as a gentle adjustment, a refinement rather than a revelation. And in keeping with its nature, the moon offered this insight quietly, without fanfare, without urgency, just another step in a long, patient conversation between observation, curiosity, and time. Once the moon's behavior is understood in its full context, it begins to feel less like an oddity and more like an example. The same quiet process that shaped the Earth-Moon relationship has been at work elsewhere for as long as gravity has had time to operate. The moon is not unusual in keeping one face turned inward. It is simply the most familiar case. Across the solar system, many moons behave in exactly the same way. Large moons orbiting massive planets almost always rotate in step with their orbits, presenting a single hemisphere to their parent world. This is not coincidence. It is the natural result of gravity acting patiently over long periods. Jupiter's major moons offer clear examples. Each one circles the planet while keeping the same side facing inward. Saturn's large moons do the same. So do many moons around Uranus and Neptune. The pattern repeats again and again wherever the conditions allow it. What matters most is proximity and time. A moon that orbits close to a much larger planet experiences strong tidal forces. Those forces flex the moon's interior, generate friction, and slowly drain rotational energy. Given enough time, rotation and orbit fall into rhythm. Smaller moons farther away may not yet be fully locked. Others may have unusual shapes or histories that complicate the process. But the underlying trend is clear. Where gravity has the opportunity to work steadily, synchrony emerges. This repetition across the solar system reframes the moon's behavior. It is not a special trick or a rare alignment. It is what gravity tends to produce when given patience and persistence. There is a comforting predictability in this. The universe is not constantly inventing new rules. It applies the same principles again and again, allowing similar outcomes to arise in different places. Once this perspective settles in, it becomes easier to look beyond moons and consider larger scales. The same process that locks moons to planets can also lock planets to stars. In other star systems, planets orbit extremely close to their suns. Some complete a full orbit in just a few days. At such distances, tidal forces are immense. Over time, these planets are expected to become tidally locked as well. For these worlds, one hemisphere may face the star continuously, basking in constant daylight, while the opposite side remains in perpetual night. The dividing line between the two regions could host unusual climates, shaped by constant temperature gradients. This idea can sound dramatic at first, but it follows the same quiet logic seen closer to home. Rotation slows, energy drains, motion settles into balance. The difference is scale and consequence, not mechanism. It is important to note that tidal locking does not make a world lifeless or static by default. Locked planets can still have atmospheres, winds can transport heat, oceans, if present, can redistribute energy. Movement does not end, it reorganizes. Just as the moon continues to rotate while keeping one face turned inward, a locked planet continues to move through space, orbiting its star and participating in a larger cosmic dance. This broader view highlights how common such arrangements may be. Many of the planets discovered around other stars likely experience some form of tidal locking. It is not an exotic fate. It is a predictable one. Gentle humour can be found in how human language often treats these outcomes as dramatic. Phrases like locked, frozen, or trapped suggest a loss of freedom. In reality, these states are simply efficient. They represent motion that has found a rhythm it can sustain. From gravity's point of view, there is no preference for variety or novelty. There is only energy flow. When energy drains away, systems settle into patterns that waste less of it. This perspective expands understanding without diminishing wonder. Knowing that the moon's behavior is common does not make it less meaningful. It places it within a larger story. The moon becomes a nearby example of a universal process, a reminder that the same quiet rules shaping the night sky also shape distant worlds, unseen but governed by the same patient forces. This realization also tempers expectations. Not every world spins freely. Not every moon shows all its faces. The universe is filled with objects that have found stable orientations and kept them for vast stretches of time. That stability does not imply stagnation. Even locked worlds evolve, orbits shift, distances change, stars age. Nothing is truly frozen. The calm comes from rhythm, not stillness. By extending the idea of tidal locking beyond Earth and Moon, the phenomenon loses its sense of peculiarity and gains coherence. It becomes one expression of a broader tendency for motion to organize itself under gravity's influence. This broader view also reinforces a recurring theme. The universe favors gradual solutions. It allows energy to dissipate slowly. It lets systems find balance over time rather than forcing immediate outcomes. The moon's familiar behavior is one chapter in that story, not the whole book. Looking outward, it becomes clear that many worlds likely experience their own versions of this quiet settling. Some may be locked tightly, others loosely. Some may still be in the process, their rotations slowly changing even now. Time is the deciding factor. Where time is abundant, gravity leaves its mark. This expanded perspective also brings a sense of calm proportion. Earth's relationship with the moon feels intimate and special, but it is not isolated. It fits into a wider pattern that stretches across planetary systems and galaxies. The same rules that guide the moon's motion guide distant planets circling unfamiliar stars. The same patience applies everywhere. Understanding this does not drain the night sky of its wonder, it deepens it. Familiar phenomena become gateways to universal principles. The moon no longer feels like a singular curiosity. It becomes a local example of how the universe tends to behave when given time and gravity. And perhaps that is part of its quiet appeal. By watching the moon, one is not just observing a nearby companion, but glimpsing a rule that operates far beyond Earth. A rule that works slowly, calmly, repeatedly. Motion falls into rhythm. Energy finds balance. Worlds settle into patterns that can last for billions of years. The moon does not keep one face turned toward Earth because it is unusual. It does so because the universe is consistent. And in that consistency, spread across countless systems and scales, there is a gentle reassurance. The same processes that shape this familiar presence are shaping worlds far beyond sight, following the same patient logic, one quiet orbit at a time. The idea of a dark side of the moon has an enduring hold on the imagination. It appears in casual conversation, in music, in fiction, and in everyday explanations offered with complete confidence. Even people who know a great deal about space often slip into using the phrase as if it describes something physically real rather than conceptually misleading. This persistence is not a failure of understanding. It's a reflection of how the human mind prefers stories that feel simple and visual. One side faces Earth, the other faces away. Light comes from one direction. Darkness seems like the natural conclusion. From a distance, the idea feels tidy. If the moon never turns, then surely half of it must live in shadow. The image is easy to picture. A bright face looking toward Earth, and a hidden half sealed off from the sun. It feels intuitive in the same way that it feels intuitive to think heavier objects fall faster, or that stillness means nothing is moving. Intuition is not careless, it is efficient. It builds explanations quickly using patterns that usually work well in everyday life. When those patterns are carried into space, however, they sometimes arrive slightly misshapen. Light, for instance, behaves differently than intuition expects. It does not care which way something faces Earth. It spreads outward from the sun, illuminating half of the moon at all times. The dividing line between light and shadow moves steadily across the surface as the moon travels, indifferent to human perspective. Yet perspective is powerful. What is seen becomes what feels real. The moon's far side is unseen from Earth, so it quietly becomes associated with darkness, even though it spends just as much time in sunlight as the near side. Language reinforces this association. Dark side sounds mysterious. It suggests secrecy and hidden worlds. Far side sounds technical, almost dull. One phrase invites imagination. The other invites clarification. It is not surprising which one sticks. There is also a subtle emotional component. Darkness carries symbolic weight. It is linked to the unknown, to uncertainty, to the idea that something important lies just beyond reach. The far side of the moon fits neatly into that emotional space, regardless of what physics says. This does not mean people are wrong to feel drawn to the phrase. It means the phrase is doing cultural work rather than scientific work. Another reason the myth persists is that the moon's behavior genuinely feels strange at first. Something that rotates should eventually show all sides. When that does not happen, the mind reaches for an explanation that feels concrete. Permanent darkness is an easy one. The reality as seen is more subtle. Rotation is happening, light is moving. The orientation is what remains constant. That distinction takes a moment to settle in, especially when the moon's slow pace hides most of the motion. Slow processes are often misread as static. When change happens too gradually to notice, the mind fills the gap with stillness. The moon becomes a fixed object rather than a moving system. This tendency is not limited to astronomy. Mountains feel immovable even though they rise and erode. Continents feel permanent even though they drift. The moon's so-called dark side is part of this same pattern of perception. Even when the facts are explained clearly, the old image can linger. That is not a problem to correct aggressively. It is something to gently outgrow. Understanding often unfolds in layers. The first layer is the simple story. The second introduces nuance. The third replaces the story entirely. None of these steps happen instantly. There's also a historical reason the phrase lasted so long. For most of human history, the far side truly was unknown. It had never been seen. Maps ended where the moon's face turned away. That absence invited speculation. When the far side was finally observed, it did not overturn the phrase overnight. Cultural habits move more slowly than spacecraft. The words had already settled into place. Gentle humour can be found in how persistent the phrase remains, even among people who know better. It's a bit like calling the sun rising and setting, while fully understanding that Earth is rotating. The language survives because it works well enough for everyday use. The goal, then, is not to banish the phrase, but to soften it, to recognise what it is pointing toward and what it is not. The moon does not have a dark side in the sense of permanent night. It has a far side that experiences day and night just like the near side. Darkness on the moon is temporary everywhere. What remains consistent is orientation. The moon keeps one hemisphere facing Earth, not because the other is hidden from light, but because gravity shaped its motion into a steady rhythm. Once that idea settles, the myth loses its grip naturally. There is no need for correction or confrontation. The explanation simply feels better. It fits more pieces together. Understanding becomes reassuring rather than disruptive. The moon has not been hiding anything. It has been behaving exactly as expected, given enough time and gravity. This gentler framing matters, especially for a topic meant to soothe rather than challenge. The goal is not to catch mistakes, but to offer clarity that feels comfortable to hold. Clarity does not have to arrive as a sharp correction. It can arrive as a quiet replacement, like switching from a rough map to a smoother one. The moon's behaviour becomes less strange when viewed through this lens. The far side is no longer a shadowy mystery. It is simply another part of the same world, shaped differently by history and gravity. Even the phrase itself can be reinterpreted. Dark does not have to mean unlit. It can mean unseen or unfamiliar. In that sense, the phrase points toward a psychological truth rather than a physical one. The far side was dark to human experience for a long time, not because the sun never reached it, but because observation had not. Once observation arrived, the darkness lifted without drama. This pattern repeats throughout science. Many ideas that feel mysterious are not hiding secrets. They are waiting for perspective to shift. The moon offers a gentle lesson in this. What feels hidden is often simply slow, distant, or angled away. With patience, the picture fills in. As understanding grows, the story becomes quieter, not louder. The dramatic unknown gives way to a calm explanation that fits naturally into what is already known. The myth of the dark side persists because it is intuitive, poetic, and culturally familiar. It fades not because it is wrong, but because something more accurate becomes easier to hold. And when that happens, nothing is lost. The moon does not become less interesting. It becomes more complete. The same face still rises each night. The far side still turns away. Light still moves across both. The difference is that now the story feels settled. There is no hidden half locked in darkness. Only a world turning patiently, sharing its light evenly, while showing just one familiar face to those watching from below. Understanding arrives not as a correction, but as a quiet relief. The relationship between Earth and the moon is not defined by a single moment or a single cause. It is the result of an interaction that has been unfolding for an immense stretch of time, shaped not by decisions or direction, but by physics doing what it does best when given patience. Nothing about this relationship was planned. Nothing aimed for a particular outcome. The moon did not set out to keep one face turned toward Earth, and Earth did not intend to become a stabilizing partner. The arrangement that exists today emerged because motion, energy, and gravity were allowed to interact for long enough. From the very beginning, Earth and Moon have been in constant conversation. Gravity pulled, motion responded, energy shifted from one form to another. Each interaction left a small imprint, barely noticeable on its own, but meaningful in accumulation. Over millions and then billions of years, those imprints added up. The moon's current behavior feels almost ceremonial in its steadiness. One face presented, one rhythm repeated, a cycle so regular that it fades into the background of daily life. Yet that calm is not the absence of history. It is the presence of an enormous amount of it. Every crater on the moon's surface records an ancient impact. Every smooth plane marks a period when the moon was warmer, more active, and more responsive to internal forces. The difference between its near side and far side tells a story about uneven heating, gravity's influence, and time spent cooling. The moon does not erase its past. It keeps it. Unlike Earth, which constantly reshapes itself through weather, erosion, and internal motion, the moon preserves what happened to it. Its surface is a quiet archive, holding on to evidence long after the processes that created it have faded. This makes the moon a kind of clock, though not one that ticks in seconds or minutes. It measures time in scars, layers, and orientations. Its locked face is not just a curiosity of motion. It is a sign that enough time has passed for energy to drain away and balance to settle in. That sense of inevitability is important. Given the moon's size, distance, and composition, tidal locking was not a surprise waiting to happen. It was the most likely outcome once the system had enough time to evolve. The word inevitable does not mean rushed. It means unopposed. Gravity did not force the moon into place. It simply allowed motion to relax into a configuration that could last. This is how many structures in the universe come to be. Not through dramatic endings, but through gradual simplification. Energy moves from complicated patterns into simpler ones. Motion organizes itself. Systems become easier to maintain. The Earth-Moon system is a clear example of this tendency. Early chaos gave way to long-term stability, not because chaos was punished, but because stability wastes less energy. There is something quietly reassuring about this process. It suggests that order does not require intention. It can emerge naturally when conditions allow and time is abundant. The moon's steady orientation is one expression of that order. Earth's continued rotation is another. Together they form a partnership shaped by imbalance, exchange, and persistence. The moon has slowed. Earth has slowed as well, though less dramatically. The moon has moved outward. Earth has adjusted its spin in response. Neither has stopped evolving. The conversation continues, just at a gentler volume. Even now the moon is slowly drifting away. Earth's days are lengthening by tiny amounts. The system is not frozen. It is simply moving at a pace that feels still. This perspective invites a broader reflection. Many things that appear permanent are simply slow. Many things that feel inevitable are the result of countless small changes that had time to accumulate. The moon's face feels timeless because it has been stable for far longer than human memory. But that stability is itself a phase in a much longer story. Before it locked, the moon spun freely. Before that, it formed from chaos. Long after now, the relationship will continue to change in ways that are difficult to imagine. This awareness does not diminish the moon's presence, it deepens it. The moon becomes not just an object in the sky, but a marker of duration, a reminder that the universe keeps records not in words or numbers, but in arrangements that persist. Gentle humour can be found in how casually the moon carries this history. It does not announce its age. It does not display signs explaining its past. It simply shows up night after night looking the same, and yet that sameness is the evidence. The fact that one face always looks back tells a story about how long gravity has been at work. It tells of energy lost, heat dissipated, and motion refined. It also tells a story about patience. The moon did not hurry into its role. Earth did not rush into its. The system became what it is because nothing interfered enough to prevent it. In a universe where collisions and disruptions are common, that continuity matters. It allowed a stable relationship to form and persist. This stability has had consequences. It shaped tides, it influenced climate, it provided a regular rhythm that life could adapt to. The moon's orientation is connected, indirectly but meaningfully, to conditions on Earth. All of this flows from a single quiet fact. Motion was allowed to continue long enough for gravity to do its work. The moon is not locked because it was constrained. It is locked because it arrived at a place where change slowed naturally. Seen this way, the moon's behavior is not strange. It is a reflection of how the universe often prefers to operate, slowly, persistently, without urgency. As attention drifts away from details and toward the larger picture, the Earth-Moon system begins to feel less like a mechanical setup and more like a long relationship, one shaped by constant interaction rather than control. They have been influencing each other for billions of years. Each has changed because of the other. Neither is the same as it was at the beginning, and yet, from the ground, the effect feels simple. The moon rises, it shows the same face, it sets, the cycle repeats. That simplicity is the surface expression of deep time. The moon, hanging quietly in the sky, is not just reflecting sunlight. It is reflecting history. A history written not in sudden events, but in gradual adjustments. Understanding this does not demand effort. It invites calm. The moon does not need to surprise to be meaningful. It does not need to reveal new faces. Its value lies in what it has already settled into. A relationship written slowly, maintained patiently, and visible every night to anyone who happens to look up. As this journey begins to ease toward its close, the moon remains where it has always been. Moving, rotating, orbiting, balanced. A quiet reminder that some of the most enduring patterns in the universe are not imposed but allowed. Time did the work, gravity guided it, and the result is a companion that carries the story of that process in its very posture, unchanged, familiar, and profoundly shaped by the long patience of the cosmos. The question that began this journey was a simple one, asked so often that it can feel almost trivial. Why do you only ever see one side of the moon? It sounds like the kind of puzzle that should have a quick answer, something neat and mechanical that fits into a single sentence. And yet, as the layers have slowly unfolded, it has become clear that the answer is not a trick, not a coincidence, and not a secret waiting to be revealed. Nothing about the moon's behavior is hidden in a dramatic sense. There is no concealed hemisphere locked in permanent darkness, no cosmic sleight of hand keeping half a world out of reach. What exists instead is a long story written patiently by gravity, shaped by motion that was allowed to continue for billions of years without interruption. The moon does not hide its far side. It simply keeps its orientation steady, the same way it has for longer than human memory. Seen this way, the moon's familiar face is not a mystery but a record. It tells the story of energy slowly draining away, of motion settling into rhythm, of a system finding balance without force or urgency. The fact that one rotation came to match one orbit was not an event to witness, but a process to allow. Gravity didn't rush it. Time did not hurry it. Together, they shaped an outcome that feels calm because it took so long to arrive. Gravity in this story is not dramatic or commanding. It does not pull things suddenly into place. It speaks quietly, continuously, applying the same influence over and over again until small effects accumulate into lasting change. The moon felt that influence when it was young and restless, when its interior was warmer and its rotation faster. Each gentle flex, each tiny loss of energy, nudged it closer to the steady state it occupies today. Nothing snapped, nothing froze. motion simply softened into order. Time is the other essential ingredient, and it is easy to underestimate just how much of it was required. Human intuition struggles with spans that stretch across millions and billions of years. Changes that feel impossibly slow from one lifetime to the next become decisive when allowed to build uninterrupted. The moon's locked orientation is the result of patience on a scale that dwarfs history, culture, and even the landscapes of Earth itself. Once this perspective settles in, the moon's behaviour no longer feels strange. A rotating object that keeps one face turned inward is not defying expectation. It is fulfilling it, given the conditions under which it exists. Size, distance, composition, and time all pointed toward this outcome. The moon simply followed the path of least resistance, shedding excess energy until it reached a configuration that could last. This understanding gently dissolves the idea that something is missing or unseen in a troubling way. The far side of the moon is not a place of absence. It is illuminated, cratered, and well understood. It carries its own history, shaped differently by gravity and heat, but no less real or complete. The reason it is not visible from Earth has nothing to do with secrecy and everything to do with orientation. And that orientation, so steady it feels eternal, is itself temporary in the grandest sense. The Earth-Moon system continues to evolve even now. The moon drifts outward by small amounts. Earth's rotation slows by tiny fractions. The conversation between them has not ended. It has simply grown quieter, its changes stretch so thin across time that they slip beneath notice. There is something quietly reassuring in this. The moon does not demand attention to demonstrate that it is active. It does not need to change its appearance to remain meaningful. Its constancy is not stagnation, but balance. Motion continues, energy still flows, but the rhythm has become smooth enough to feel like stillness. The same forces that shape this familiar relationship are at work everywhere else in the universe. Moons around distant planets settle into similar rhythms. Planets close to their stars slow and align. Systems evolve not toward drama but toward states that waste less energy. The moon is not an exception. It is a nearby example of how the universe often prefers to operate when nothing interferes. Returning to the original question with this wider view, the answer becomes both simple and deep. You only ever see one side of the moon because gravity had time to do its work, because energy was allowed to drain away slowly, because motion found a rhythm it could sustain. There is no trick beyond that, and no mystery hidden behind it. The moon's steady face is a reminder that some of the most profound changes do not announce themselves. They arrive gradually, settling in so thoroughly that they come to feel inevitable. By the time they're noticed, they have already been in place longer than anyone can remember. This perspective invites a softer way of looking at the night sky. Instead of searching for surprises, it becomes possible to appreciate continuity. The moon rises. It follows its familiar path. It shows the same face it has shown for billions of years. And in doing so, it carries the quiet evidence of how long gravity has been shaping its motion. There is also a subtle comfort in knowing that nothing dramatic is waiting just out of sight. The universe does not need hidden sides to be interesting. It needs time, it needs patience, it needs processes that are allowed to unfold without interruption. The moon is interesting not because it hides, but because it remembers. Every night it appears, it reflects sunlight back to Earth, but it also reflects history. Its posture is a record of deep time, written into its motion rather than its surface. A reminder that the universe often tells its stories through arrangement rather than spectacle. As attention drifts back to the present moment, the moon remains what it has always been during human history. A steady presence, a familiar companion, something that can be counted on to return, unchanged in orientation even as its light waxes and wanes. There is no need to imagine unseen drama or concealed darkness. The moon does not withhold itself. It simply turns at the same pace it travels, keeping its rhythm consistent, its motion smooth, its behavior calm. Understanding this does not diminish the moon's quiet power, it enhances it. The same face rising night after night is no longer just familiar. It becomes meaningful, a visible sign of how gravity and time cooperate when given the freedom to work slowly. So when the moon appears again, pale against the dark sky, it can be seen not as something frozen or fixed, but as something balanced, still moving, still changing, still part of a long interaction that began in chaos and settled into calm. The question has an answer, but the answer does not close the story. It opens it outward, toward a universe where motion rarely stops, where change often whispers rather than shouts, and where some of the most enduring patterns are created not by force but by patience. The moon remains there, steady and familiar, carrying the imprint of billions of years in the simple fact that it always shows the same face. Not because it must, but because time allowed it to become so.